solve the triangle having two sides given to us. We have the side A with 40 units and side C that's 40 times square root of 3 units. And we also have the angle that lies between the two sides that's given as 30 degrees. Our goal will be to solve the triangle. Okay, let us begin. What we'll do first, we are going to consider a triangle with vertices A, B, and C. Then what we'll do, we are going to consider the angle A. So the side opposite to angle A, which is BC, we're going to denote it by the letter A in lowercase. It's given here that this is 40 units. Then we consider the side that is opposite to angle C. We're going to denote it by the letter C, and it is given as 40 times square root of 3 units. And then we have the side B, which is the side opposite to angle B. Okay, it's also given here that the angle B has a measure of 30 degrees. Now this is the angle that lies between the two adjacent sides A and C. So using this information, we'll try to find out the angle measure of A as well as C and also the measure of the side B. Okay, to begin with, what we'll do, we are going to use the fact we know that the sum of the three angles of a triangle add up to 180 degrees. That means we have A plus B plus C, that's equals to 180 degrees. Now we have the measure for angle B, so that's 30 degrees, which means our equation is going to be A plus C equals to 180 degrees minus, so transpose the B to the right hand side and replace it with 30 degrees. So that is going to give us 150 degrees. So we have one equation, A plus C equals to 150 degrees. Fine, we're going to keep it aside. Our next task will be to find out the equation in terms of A minus C on the left hand side. To do that, so we're going to make use of the half angle formula. So we know that tangent of, now what we need A minus C. So we'll take the half angle of A minus C, and this is going to be equals to, we have A minus C divided by A plus C multiplied to cotangent of B over 2. Okay, let's use our value. So A here is given as 40 units. So we're 40 minus C. So angle C measure, that's 40 times square root of 3 whole divided by 40 added to 40 times square root of 3 multiplied to cotangent of the angle B, which is 30 degree here. So 30 over 2, that's going to be 15 degrees. That comes out to be equals to 1 minus square root of 3 divided by 1 plus square root of 3. So here we have factored out 40 from the numerator and the denominator. Next, we need to compute the value of cotangent of 15 degree. Now, cotangent of 15 degree, there we can easily find out the value. All you have to make use of the fact that cotangent of 15 degree. Now, 15 degree can be also expressed as 45 degrees minus 30 degrees, right? Which means that we can rewrite it as the ratio of cosine 45 degrees minus 30 degrees divided by sine 45 degrees minus 30 degrees. Now when we can easily expand cosine of 45 minus 30 and sine of 45 minus 30, that I'm leaving as an exercise for you to try out. And once we do that, we're going to get the value square root of 3 added to 1 divided by square root of 3 minus 1. So this is going to be the value for cotangent of 15 degree. So let's substitute in place of this cotangent 15 degree. We have square root of 3 added to 1 divided by square root of 3 minus 1. Now what we can do, we can factor out, but this is going to leave us with a factor of negative 1, which means that we have obtained that tangent of A minus C over 2. So that comes out to be equals to negative 1. Now we know that tangent of 45 degree, that equals to negative 1, which means that we have negative tangent of 45 degree. Furthermore, tangent is an odd function, which means that we can rewrite negative tangent of 45 degrees as tangent of negative 45 degrees. So here we have considered the fact that tangent of negative theta, negative of an angle theta, that is going to be equals to negative tangent of the angle theta, because tangent is an odd function, which means we can now get rid of the tangent function of both sides to get A minus C over 2. That is going to be equals to negative 45 degrees. So now we have A minus C, that's going to be equals to negative 90 degree, and that's going to be our second equation, number 2. So we have obtained, well, the first equation, a plus c equals to 150 degree, and then we have a minus c equals to negative 90 degree. So what we can do, we can easily solve both of the two equations. So solving 1 and 2, I'm leaving the solving part uh, as an exercise for you to try out. So angle A, that comes out to be 30 degrees, and angle C, that comes out to be 120 degrees. So we have successfully obtained the angle measure of A. So A, that is 30 degrees, and then angle measure of C, so that came out as 120 degrees. Okay, and now we have one final task, that will be to obtain the measure of the side B. To do this, what we'll do, we're going to take the help of the law of sine. So the law of sine simply states that the ratio of A to that of sine of the angle opposite to it, which is angle A, that's going to be equals to the ratio B over sine of angle B equals to C over sine of angle C. So here, since we need to obtain the measure of B, so we're going to consider this ratio B over sine of angle B. And we're going to equate it with the first ratio A over sine of angle A. Fine. We can use the second ratio as well. Both of them are going to yield the same result. So B must be equals to A times sine of angle B, sine of angle B divided by sine of angle A. So here A, that's 40 units multiplied to sine of angle B. Sine angle B, that's 30 degrees divided by sine of angle A. So A here is also 30 degrees. So we can easily factor out the numerator and the denominator, and that leaves us with 40 units. So here B also comes out to be 40 units. So we have successfully solved the triangle.